Hello viewers, now we will see assumption made in Euler theory. See first bullet point, the column should be axially loaded. So for that, I will give you one example. Let us assume that this is one column. See, this column should be axially loaded. Like this. Second bullet point is, the column material is perfectly elastic. See, in our first chapter, we had seen that what is elasticity. Elasticity is the property of material by virtue of which it regains its original shape and size after deformation when the load causing deformation are removed. See, when we give load to that, see this red color load, we applied here, and due to that load, this column deforms slightly, little bit like this up to here. And when we remove this load, then this column will like regain to its original position. So this is meaning of that perfectly elastic and not plastic. Now second is, the column material is perfectly elastic, homogeneous. So now homogeneous, that means properties same at every point. Properties like modulus of elasticity, Poisson's ratio are same at every point, like here, etc. At every point it should be same. That is meaning of that homogeneous meaning, homogeneous word. And isotropic meaning is property same at every direction. Like if you consider this as x direction, this as y direction, and this as z direction, that means this property should be same at every direction. Property should be like any like physical property, like a modulus of elasticity, Poisson ratio in that sense. And thus obeys Hooke's law. Hooke's law, we had seen that obeys Hooke's law. Within proportional limit, stress is directly proportional to strain. So this is Hooke's law. If stress increases, then strain increases. This is Hooke's law. So now third bullet point is, column should be perfectly straight and uniform in cross section. See this column, this is perfectly straight, and this should be perfectly straight and uniform in cross section. Like section of that column here at xx and at yy should be same. That is the sense of that sentence. Did you get that point? That means section, that means see, if we cut here x, it is like square, like AB dimension, and if we cut here yy, it is similar to that section yy. Okay, A, B, like that. Length of column is very large as compared to its cross section. See, if you consider this as length of column, then it should be greater than that A, B. A, that means this is A, this is B, like that. This is meaning of that sentence. Now next is, column is long, that means direct stress is insignificant compared to bending stresses. See, When column is long, then bending stresses are always maximum. See, due to buckling, there are stresses come. See, for buckling, only line diagram I will show you. If column buckles like this, if it fixed at top and bottom, if it buckles like this. So due to that, here bending stresses occurs more than that of direct stresses. So this is meaning of that fifth bullet point. Now next is plane cross section of the column remains plane and normal to the center line during the buckling. See, plane cross section, that means like this. This plane cross section remains plane. That is meaning of that. That is. So for that we need to draw this diagram neatly. See, this column is like this. This is straight line. Consider this as a straight line. See, this column is buckles like this. Like this, it is buckled. So if you see that here at this location, this is original cross section of column. This should be same here at buckled location. This is like plane cross section of the column remains plane and normal to the center line of section. That means it should not be like bend type. It is remain plane and normal to the that buckling behavior. Like this is meaning of that sentence. And one important point here is self weight of the column is neglected. So these are all assumptions of the Euler's theory. First is column should be axially loaded. Second is material is perfectly elastic. Column material perfectly elastic, homogeneous and isotropic, and obeys Hooke's law. So this is material assumption. First is load assumption, and third is column should be perfectly straight and uniform in cross section. So third is geometrical assumption. Fourth is length of column is large. Fourth also geometrical assumption. The column is long and direct stresses insignificant compared to bending stresses. Yes, and the plane cross section of the column remains plane and normal to the center line of the section. And this is important. Self weight of the column is neglected. So okay, thank you very much.